Sorry. Okay, I'm going to review it. So we are going to finish our duty here. We did the C. I remember an example 8. I leave it for you as a homework. And I told you the idea is like that. The idea, we have that one. So I'm just bringing it to up. We have 2z dz. You can see also in the video, the previous video, we change this one as a minus 1/3. We bring this one to up. So you have z squared plus 1. And you know, the derivative of here is equal to 2z. That's why. So I'm going to solve it nicely for you. We have what? We have, we see we have, this one will come to up. So it will be minus 1/3. You know, this one is equal to 1/3. The cubic root is equal to 1/3. Then we will bring it to up, it will be minus 1/3. And here we have z squared plus 1. Then here we have 2z dz. You can see derivative of here exists. Directly you can put plus this one by 1 and divide by the new exponent. So we are going to new subject here. This one is not very important because we did it before, I think. Don't know. Record. Okay, good. So directly we are going to what? To 5.6. Here we have what? We have definite integral, substitution, and the area between two curves or between curves. Curves means that we have two or more functions. Look at here, dear. Definite integral is like indefinite. Sorry. Hello. Definite is like an indefinite integral, but does we have a boundary. So for solving that one, how we solve it as a previous one. So today, like a review, then we are going to solve something else. When I say review, you know, look at the example. Look at here. We have that example. So how we solve it? We have 3x squared . 3x squared, okay, what else? And also we have x cubed plus 1 dx. But also we have boundary here from -1 to 1. So that one is called definite integral. You can see we have a definite integral. So how we find the definite integral? As I told you, easy. I think we mentioned before. First, you try to substitute the upper, then second, the lower. How? Like that. First, I'm going to arrange it. I see -1 to 1. In my mind, I'm going to solve it without what? Without limits, without boundaries. So here we are. X cubed plus 1, 3x squared dx. And I'm going to change that one, as we mentioned, as what? As a power, as an exponent. So it will be what? It will be -1 to 1. That one will be x cubed plus 1, 1/2, 3x squared dx. You can see between this example, this one, and the example 8, the previous one, there's no difference. Just one plus minus exponent. So derivative of here is equal to what? Because I have a brackets, I told you if you have a parenthesis with the exponent, just think about, you have u maybe outside du. So I'm going to check that one. Is that one, is if this one, I put it in u in my mind. I'm asking myself, do you exist or not outside? You can see the derivative of it is equal to 3x squared dx. If the 3 is not exist, we can't put the number, right? But if the variable does not exist, that's the problem. So because everything is true, everything is provided, so we don't need to. So just we have u du, so we can solve. We can solve. How? I'm going to say that is equal to x cubed plus 1/2, 1/2 plus 1 divide 1 over 2 plus 1. But instead of saying C, I'm going to substitute this boundary. So I'm going to write down like that. I say is equal to, or from -1 to 1. And you know, that one will be 3 over 2. And that one will be cube 1, 3 over 2. Here remains. And I'm going to do my algebraic things. I'm going to say 2 over 3. So x cubed plus 1, 3 over 2 from -1 to 1. Because we have a boundary, first of all, try to substitute upper boundary. So I'm going to write down like 2 over 3. I'm about to up to you can use it again inside. So I will write something minus another thing. Also, you can write like that. Instead of that, just write 2 over 3 to be more simple. Understood? The same. So I'm going to substitute the first boundary, as I say. This one be by the color, by that one. So this one will be the first limit that I'm going to substitute it. So I have cube plus 1, cube plus 1. For the first, I'm going to use 1. For the second, I'm going to use minus. You got it? So first minus second. Easy, right? So this one is the definite. Means that you have the value and you should substitute it. When we should do, when we put that one, when shall we put that one? At the last step, when we finish everything, when we solve like indefinite without boundary, when we solve everything, then we are going to substitute. That's all. So you get the number, you know, 1 by 1 is equal to 2 minus 2 over 3 minus 1 is equal to 0, and you get 4 over 3. Understood? Easy, right? Just put the value. Oh, sorry. Where's the mistake? This one is 3 over 2. Oh, mistake. This bracket is what? 3 over 2, 3 over 2, right? So I'll get 3 over 2, 3 over 2. So the value will change. Let me do it again for you. Shall I do it or you understand? I forget the exponent. I will do it for you. Okay, it's okay. I'm going to do it again here. Okay. -1. So we say is equal to 2 over 3, first bracket minus second bracket, 2 over 3, second brackets, okay? So for the first bracket, we have what? We have 3 over 2, something cube plus 1. And again, 3 over 2, something cube plus 1. For the first, we are going to substitute 1. For the second, we are going to substitute -1. So in that case, I'll get 2 over 3, 3 over 2, minus 2 over 3, 0, 3 over 2. For the first, we get what? 2 over 3, multiply, you can say 8 to power 2. And here we have 0. And you know 8 to the power 2 is equal to 2 square root of 2, and 2 over 3 was equal to 4 square root of 2 over 3. That was the mistake, sorry about that. So do not forget anything, any detail here that we have. Question? Question? Good. Next example. Yalla. We have what? Cotan, cosecant square. Wow, a large with pi and minus pi. Look at here. So how you solve that one? Maybe you'll leave it because you say it's not easy, but actually is one step. So I'm going to write here, example 2. You say it was pi over 4, pi over 2, pi over 2. Okay, the function is what? Cotan cosecant square theta cosecant square of theta d theta. So how we solve that one? I gave you one page, right? That was contain everything. So now how we solve this example? The previous lecture, I gave you one page in the PDF, you can review it. I gave you 6 basic or direct trigonometric functions. Okay, how to solve that one? I mean that one. So how we see that if you have 2 functions together, this is the review. If you have 2 functions together, okay, 2 functions together, make one of them, for example, I have sine, I will erase that one again. So if I have sine of x, cosine of x, dx, how we solve that one? This is the 3rd time I'm going to solve this example. So how we solve that one? I say today I have a list, right? I say today I'll bring the list and I'll mention your name. So how we solve that one? Sorry? Sine 2? No. We didn't know. Okay, how we solve that one? Okay. 50% discount. How we solve that one? Yeah. Okay. Just equal to what? What do you mean by minus cos? The result? No. This one new. That one due. Derivative of sine, cosine. So I'll get what? Am I right? Hello? You remembered? Okay, I hope. Okay. So how about if this example, I change it to that? How about that one? X? No. X sine to power 3. Okay. Easy. Why? Because I have u square in my mind and I have du. We say that. And I give you many notes about that, right? You got it? Okay. Next level. That's simple. Next level. If I have tan of x, secant square of x, dx. These ones, they are together and they are opposite each other. When I say opposite, I didn't mean inverse. I didn't reciprocal. I mean about the derivative and antiderivative. So I'm asking myself, derivative of tan is equal to what? 1 over, so is equal to secant square. You are right. So means that you have here is u. That one will be what? Du. So how I solve that one? I see is equal to what? Like a sine, tan square of x over 2 plus c. Why? Because here's to power 1, u inside exists, du exists outside, so I'm just going to add them. Another level. If I have tan of x to power 3 secant square of x dx. The matter is not how the power tan we have, how the power, how many, or the power of sine is equal to what? The power of tan is equal to, no, there's the important thing is not here. The important thing is here, if I have tan, derivative of exists or not? That's the question that you are asking yourself. Exist or not? Exist. So it's equal to what? Tan power 4. Again, tan to power 4 over 4 plus c. Now, if I have cotan, cosecant square, I'm asking myself, derivative of cotan is equal to what? Like a tan, look, like here. So is equal to what? Yeah, we need the minus here because derivative of cotan is equal to minus cosecant. So I need one minus here. Okay, that's the minus. Now we have a power. Derivative of u exists outside the du. So I'm going to say what? I say is equal to cotan square over x over 2 plus c. Am I right? And do not forget about minus that we have. Easy? From the simplest one to the difficult one. You got it or not? Good. So in case I have pi over 4, pi over 2, cotan x or theta, cosecant x or theta is equal to what? Is equal to nothing because here should be square. So in that case, is equal to what? Is equal to minus cotan x over 2 square from pi over 4 to pi over 2. And use, say, is equal to minus cotan square over 2 minus again minus cotan square over 2. This time use pi over 2. That time use pi over 4. And you get the result. I don't know, you know how to find the pi, right? Because I gave you the table. Do you remember that? Good. So you need actually study. If you didn't understand, if you can't solve that one because I mentioned 3 times, 4 times, it means that you didn't even listen to me. That's the problem. Anyway, so we have this example. You can see he changed to u. He changed the boundary. You can see during the study, but we don't care about that rule, okay? He used the u du. So I'm going to use, I used what? I used the direct method that I have. Up to you. If you follow that one, you know how to change that one. How we change pi over 4 to 0 and 1, pi over 2 to 0. So you know how to change that one. And if you know, otherwise you'll get the same result. Same result. Any question? Any question? Okay. Do you have exam during this week? Yes. We are not solving by the derivative. We are solving by what we have. We say that if I have just sine of x dx, this one is direct. You don't need to derivative. So this one is direct. I say is equal to minus cosine x plus c. But if I have sine with cosine of x, I'm going to use u d. Understood? Here I say is equal to sine square of x over 2 plus. You got it? If I have sine square of x, how we solve that one? We say we cannot directly solve that one. We should change it, then we are going to solve it. Depends on the example. There is no everything like a one rule. No, it's like a chess. You should use your mind. But it's not difficult because the rules are not a lot. If I have a direct, I have a direct result. If I have a u du, means that something with a derivative, so I'm going to add the exponent, divide by the new one. اگر اكسري بو اكسر دانم اگر هاتو دو نخشه و دريفيت في يكون يشان نخشكه بو كان دريفيت فكيبو تو انا جو نخشكه دانم دا باش توين تازيكم. If I have something that stuck me like that, sine square, I'm going to change. The previous example lecture we solved that one. You can review the things. So we say we will going to change that one to that. And that one is easy. We cannot direct something, solve it. Also, we have a derivative outside. So how we solve it? We change it. Can you see? So it depends on the example. I don't say everything we need a derivative outside. No. That's a 3 example with sine. Sine, sine square, and sine cosine. You got it, Kak, again? Okay, now look at here. We have this example. 1 sine square x to power 3. Whenever you, at the beginning, you may be afraid. You say, oh my goodness, that all 1 plus sine square x, all of them to power 3. Look at it. Okay, what else? 2 sine cosine. 2 sine of x, cosine of x dx. With what? With the boundary 0 and pi over 2. Yeah. At the beginning, actually, I am afraid from that example. We have sine, we have plus, we have square, we have cube, we have a fraction, right? But it's easy. Bring it to up. Today, this is the third example that we bring the exponent to up. So bring it to up, you will get the easy things. How? I say from 0 pi over 2, 1 plus sine square of x minus 3. Am I right? And here we have 2 sine of x, cosine of x dx. Now I'm asking you, which rule we can apply from these 3 that I gave you? This is direct. Can I say is equal to that one? No. So I have 2 things. Maybe one of them the derivative of the other, right? I'm asking myself. So let me check. Derivative of here, not here, just here. U. So here's U. Just the blue one. So U is equal to 1 plus sine square of x in my mind. So I'm asking myself, do I have derivative or not outside? Let me check. Derivative of sine, this one is equal to 0. Derivative of here is equal to 2 sine of x, derivative of sine, cosine of x. So I have it. If you don't know, even, let me give you another review. If you don't know how to find that derivative, we say that this one is equal to that one. Am I right? Oshman. So du is equal to what? 0 plus. How to find the derivative of the bracket? Derivative of 0. Yes, exponent come to down, we raise down that one. So derivative of here minus 1. يقدر توانكي كما كينو. لقداني now كوانكي كده تشوينا كنا so cosine of x. You got the same thing. Am I right? You got the same thing. So this will be what? Kakar. Yeah. du. Am I right? U du. So how we solve U du? We add 1 to here. So I say 1 plus sine of square of x. اگر یکی بازی اگه چی if you add 1 minus 2. Am I right? Okay. Over minus 2 plus c. Or you can say from 0 to pi over 2. Easy or not? Depends. Depends on the example. But the idea is not a lot. The idea is not, oh, how many times? No, we have some 3-4 idea. Just recognize it, order it, arrange it, I mean, then you can find the solution. Understood, Kaka? Okay, now, next, how we solve that one? Can you help me? Day. So I'm going to put, arrange your come. I'm going to put 1 over, or with a minus, 2, 1 plus, 1 plus sine square is equal to what? No, you are wrong. It's not equal to anything. If there's a minus, then you are right. Thank you. So sine square of x. So if you know why you are asking, right? Just for thinking that you are thinking wrong. So I put the down because I have minus, or you can use it, up to you. Minus 2, it's okay. But I'm going to use that one. I think it's easier for me. Now, first box minus the second box. First box is like that, minus 1, 2, 1 plus sine square of something. Okay, second box the same, minus 1, 2, 1 plus sine square of something. Then we have pi over 2, 0. Understood? Easy this one. Pi over 2 is equal to what? So minus 1, 2, 1 plus 1, right? All right. Again, minus 1, 2, 1 plus 0. Am I right? It's equal to, that one will be minus 1 over 4, minus plus 1 over 2. And equal to 1 over 2. Yeah. You got it? So it's equal to, for example, 8. Or you can say 4. Why 8? So minus 1 plus 2, 1 over 2. It wasn't easy, but it wasn't hard. If you try to study more, find 3, 5 more examples, you can see you will solve it easy by that one. Again, wallah, you are right. Again, I forget the same mistake. 2, here's 2, so okay. 2, 2, I'll get what? The same mistake. Okay. I'll do one bit careful. So you have 2. It will be minus 1 over 2, 4, 8, right? Minus is equal to 0, minus 1 over 2. And 8 minus 1 plus 4, 3 over 8. Thank you. Any question? The same idea, the same rule, the same strategy. That's all about the things that you have. Before we take a rest, so we have 2 more rules, which maybe you are going to use it or not. The rule is what? Like another rule, like a property. Let me say property is not rule actually. Let's say the function is odd or even. So there's a relation between type of function and what? and boundary. Look at here. For example, look at this example. Minus a means that minus a to a means that from minus 2 to 2, minus 1 to minus 2, 1. Understood? Okay? So like that. If you have the boundary, the same boundary, minus 3 to 3, okay? And the function is odd or even. So if the function is odd or even. For example, I have, give you more easier one. I have from minus 1 to 1, I say find the area, for example. Minus 1 to 1. Area means the integral. X squared dx. I know x squared is the even function. And I know I have minus 1, a to 1. So I'm going to do like that. I'm going to change the boundary to half, okay? To half, minus 1 to 1. So I'm going to change it to half, okay? And I'm going to multiply it by 2. Understood? For example, I have cosine. I say from minus pi over 2 to pi over 2 cosine of x dx. I know cosine is even, so I'm going to write like that. They tell me about the boundary. 0 to pi over 2. You got it? Look at the function. If I want to find here, because I have a cosine, from minus pi over 2 to pi over 2, instead of finding here and here, I'm going to find just 1 by 2, because they are the symmetry. Symmetry means that the same shape. If I have 2 here, I have 2 here, there. Understood? So that's why instead of these all duration, these all period, these all length, I'm going to use half. It's not very important, just for your information. How about if I have odd function? If I have odd function, in that case, if without using anything, you'll get 0. Do you remember we solved that example before? We say from 0 to, like that, pi to pi sine of x dx. Instead to find the value and you get 0, just you say I get 0. Why? Because this one is odd and that one from minus a to a. Okay, dear? Easy? That's all. Maybe you use, maybe you don't use it. Depends on the example. So here we are. Example. Question number 1 or 2. So one of them, total area or that one. Total area or that one. One of them will come to you. So study well. I'm going to stop here for the rest. Okay. Then